Bismillahirrahmanirrahim. In this lecture, we are going to speak about the finite difference operator and difference equation. Start by defining the finite difference operator. The difference operator is defined by the form or the formula is defined by delta yn equal to yn plus 1 minus y sub n. So just operator to find the difference between any successive values of a function. We have a function y, and finding the difference between any two successive values of that function will give me or is called the difference operator. So delta y sub n equal to y sub n plus 1 minus y sub n. From this one, we can find up to different powers of the operators. And any equation contains one of the or one form or order of the difference operator, we call it difference equation. What's the definition for that? Difference equation. Equation is any equation or any equality, not say equality, not equation. Involving difference between successive values. Of a function. We call this is difference equation. It is any equality involving difference between successive values of a function. Before giving an example about a difference equation, let's deal with the difference operator. We define the difference operator to be the difference between any two successive values of the function. So for this, from this definition, we can find the different powers of difference operator. For example, delta square of y sub n can be written as delta multiplied by another delta. That will be delta of y sub n. From the definition, it is y n plus 1 minus y sub n. By the distribution property, this will be delta of y n plus 1 minus delta of y sub n. So we apply the definition for each one of these. Delta of y sub n will give me y n plus 2 minus y n plus 1. This is the first one. Minus delta of y sub n equal to y sub n plus 1 minus y sub n. This will give me y sub n plus 2 minus 2 y n plus 1 plus y sub n. So delta square y sub n equal to y n plus 2 minus 2y n plus 1 plus y sub n. This using the different notation, it will be e minus I all to power 2 or something called the shifting operator. Now the shift operator E is defined by E sub n equal to y n plus 1. Just shifting the value to the next one. N became n plus 1. So delta sub n, this will give me delta of y sub n, which is equal to y n plus 1 minus y sub n. But y sub n plus 1 is equal to the shifting operator for n. Taking n as, or y sub n as a common factor, I will have e minus I. I is the identity y sub n, which means delta, the difference operator equal to the shifting or e minus I. Have this relation. Delta or the finite difference operator equal to the shifting minus the identity. E minus R. And from this one, we can find the general form. We can say that the general form or general formula delta to power n equal to e minus I to power n. This is the general formula. Delta to power n equal to e minus I or to power n. And from this one, we have this list. 1. It says that y sub n plus 1 equal to e sub n. 2. Y sub n plus 2 is equal to e square sub n. 3. The general form n plus k is equal to e to power k y sub n. Let's have some example for this shifting operator and the difference operator. Example. Let's rewrite in a form three of the operator delta. Number 1. Suppose I have delta square of y sub n plus 7 delta y sub n minus 18 equal to 0. And I need to write it in a form free of the operator delta. Means that I'm going to use the shifting operator. From the relation or the general form, e to power n equal to e minus I o to power n. So delta square can be written as e minus I square y sub n plus 7 multiplied by e minus I to power 1 y sub n minus 18 y sub n equal to 0. This will give me e square minus 2 e using the special product, or bfx squared is e squared minus 2 e plus I y sub n plus 7 multiplied by e minus I minus 18 y sub n equal to 0. This will be e square y sub n minus 2 e y sub n plus y sub n. The identity multiplied by y sub n equal to y sub n plus 7 e y sub n minus 7 y sub n. Minus 18 equal to 0. Now e square y sub n will give me y sub n plus 2. Shifting the value by 2. Minus 2 multiplied by y sub n plus 1. Shifting just 1 unit or 1 value. Plus y sub n plus 7 times y n plus 1. These two together, you can combine them, will be minus 25. Equal to 0. So I will have y n plus 2. This one with this one will give me plus 5. Y n plus 1. And we have y sub n and minus 25. Y sub n will give me minus 24. Y sub n equal to 0. And that's it. We wrote the difference equation in a form free of the operator delta. It is y sub n plus 2 plus 5y sub n plus 1 minus 24y sub n. Take another example. Number 2. Delta to power 3 y sub n plus delta y sub n equal to 0. Again, we need to write it as or in a form free from the delta. Delta is equal to e minus I to power 3 y sub n plus delta sub n equal to 0. Or not delta, we write it as y sub n equal to 0. This is equal to e to power 3 minus 3 e to power 2 plus 3 e plus or minus I. Expansion 4 using the identity a minus b to power 3 is equal to a to power 3 minus 3a square b plus a or 3a b square minus b to power 3 using this expansion. So this is the first one, y sub n plus second one will give me y n plus 1 minus y n equal to 0. So e to power 3 times y to power n, it will give me, or y sub n, it will be a or y sub n plus 3 minus 3 y n plus 2 plus 3y n plus 1 minus y sub n, and this will be plus y n plus 1 minus y sub n equal to 0. I can combine the similar terms. 3y sub n plus 1 plus y n plus 1 will give me 4, and minus y sub n and minus y sub n is minus 2y sub n. So this will be y n plus 3 minus 3 y sub n plus 2 plus 4 y n plus 1 minus 2 y sub n equal to 0. So the equation or the difference equation now is written in a form free from the operator delta. So this is how to deal with the difference operator and how to convert the difference form into equation free from the given delta so that we can solve it. We need to find the solution. The next point is to solve the difference equation and find the solution for the difference equation. That will be given in the next video. So in the next video, we are going to find the solution for the difference equation.